Hello, everyone, and welcome to Rational Expressions and Equations Lesson 7. So just like throughout most of this unit, 7 and 8 kind of tie together. So this is essentially your last two blocks of unit or lessons, and then we're done. Yay! So today we're looking at rational equations. So far we've just been looking at rational expressions, and now we're going to look at rational equations. So it says here, a rational equation is an equation in which at least one of the terms is a rational expression with a variable in the denominator. So I'm going to show you how to solve these using a graphing calculator, but the main focus of this lesson is going to be solving them algebraically. So this will be more just for fun here. So if we have this equation here, 3 over x plus 1 over x minus 1 equals to 2, that's a rational equation. You can see we have that equal sign there. And we want to solve for the value of x that makes this equation true. So there's a couple different ways we can do it. We can do it the intersection method or the x-intercept method. In the intersection method, we're going to graph the left side of the equation, we're going to graph the right side of the equation, and we'll find out where they cross. So I've done that. If you follow me to Desmos, you can see I've graphed both of them, and where they cross is here and here. So the x values of where they cross are going to be your solutions. So you can see 0 and 2 are the solutions. So x, draw, go. There we go. A little bit of a hesitation there. X is equal to 0 and 2. Using the same, I'm not going to draw the graph just because we're not going to be doing too much of this, but the x-intercept method on the same equation is, what you do is you're going to make everything equal to 0. So, of course. So what you're going to do is subtract 2 from both sides of the equation above, and then you can see that we have 3 over x plus 1 over x minus 1 minus 2 equals to 0. So if you graph that whole left side, the solutions will be where we cross the x-axis or your x-intercepts. So you can see, if we go back to Desmos here, I'll get rid of these two lines that we had before. We already know the solution should be 0 and 2. So if I bring up that one, you can see that we cross at 0 and 2. So our answers, x is equal to 0 and 2. So that is how you would use graphing to solve these equations. And graphing is a good way for you to double check that you have the right answers. But what I'll be looking for mostly in this section or this lesson is, can you solve it algebraically? So there's some steps here. The following strategies should be considered when solving rational equations algebraically. It says here, if the equation consists of a single rational expression on each side, you can use cross multiplication, which is, I'll show you how to do that one. This will be example B. If the rational expression has more than one term on either side, consider multiplying each term in the equation by the lowest common multiple of denominators. This is example A, just below here. And then it says, use previously learned skills for solving linear or quadratic equations, and always be aware there are domain restrictions when dealing with rational functions, and check your solutions accordingly. So if we say that a non-permissible value is 0, and then our solution is 0, then it doesn't work. There isn't a solution because it's not permissible. That's not allowed. So let's just jump into some examples here. So the first one is 4 plus 2x, or 4 plus 2 over x is equal to 7 plus 3 over x. So if we go back and read this one here, it says if the rational equation has more than one term on either side, which this one does, it's got 2 terms on either side, consider multiplying each term in the equation by the lowest common multiple of the denominators. So in this case, we want everything to be over. We want to multiply everything by the lowest common denominator. Here we have a denominator of x and a denominator of x. So I'm going to multiply everything by x. That's the fancy x, so you don't get confused. Maybe I'll just write it like this: multiply by x. So before we do anything, we want to say that our non-permissible value here is 0, right? X can't equal 0 because then we would get a 0 in the bottom and we'd be dividing by 0 on 2 accounts, and we just can't have that. So now if I multiply everything by x, you're going to see that we can rewrite our equation as 4x. This x over x here cancels, so then it's 4x plus 2 is equal to 7x plus 3 over x times x, so those x's cancel. So now our equation is 4x plus 2 is equal to 7x plus 3, and we can solve this. So basically we want to get everything that's an x term on one side and everything that's a constant on the other side. So I can subtract 4x to both sides, and I'm left with 2 is equal to 3x plus 3. Then I could subtract 3 from both sides, and I'm left with 3x on this side and negative 1 on this side. And then I can divide by 3. I probably took up way more space than I needed. So those 3's cancel, and I'm left with x is equal to negative 1/3. And we can see that it's not our non-permissible value, so this is a good solution. It does say in the top, verify the solutions. So what they want you to do is go back to the original equation. So the left side is 4 plus 2x. So now we're going to plug in our x solution there. So 4 plus 2 over negative 1/3. And then 2 divided by negative 1/3. I'm not going to go over dividing fractions too much, but when you do that, you're going to get 4 minus 6, and then you get negative 2. And then you can do the same thing on the right side. So it's going to be 7 plus 3 over x. So 7 plus 3 over negative 1/3. And then we are going to get 7 minus 9, which is negative 2. So you can see that the left side is equal to the right side. So that solution works. So you should be able to check every one of these to see if they work, if you want to, which I would recommend if you want to know you got the right answer. Okay. In this case, we have only one term on either side of the equation. So I'm doing B now. So if we go back up, it says if the equation consists of a single rational expression on each side, use cross multiplication to simplify the equation. So what we can do is we can actually use cross multiplication, which means we're going to multiply 5 by that denominator and 2 by that denominator, so that we get 5 multiplied by x plus 2 is equal to 2 multiplied by x plus 1. We want to state our non-permissible values before we do anything. So x cannot equal negative 1 or negative 2. And now we can simplify. We know that that 5 multiplies into both terms in that bracket there, and the 2 multiplies into both terms in those brackets there. I'm going to do 2 steps of algebra in one. Hopefully that doesn't confuse anybody. I'm going to subtract 2x from both sides and then subtract 10 from both sides. So then I get 2x cancels and the 10 cancels. I'm left with 5x minus 2x is 3x, and 2 subtract 10 is negative 8. And then I'm going to divide by 3 to both sides, so that I get x is equal to negative 8 over 3. It's not a non-permissible value, so that's a good solution. We could verify the solution if we plugged this value in to both this side and that side and checked that they were equal. I'm not going to go through that, just in the spirit of getting through this video quickly. Okay, let's go on to another one. So it says here, state the non-permissible values and solve the equation algebraically. So in the first one, we only have one rational term on either side of the equation, so we can use our cross multiplication to solve. But the first thing we want to do is say that x cannot equal -3/2 and -5/3. And now what I'm going to do is cross multiply so that I have 4x minus 2 all multiplied by 3x plus 5, and that's equal to 6x minus 1 multiplied by 2x plus 3. So now what I want to do is expand everything. So I'm going to FOIL everything. So this one here, if I FOIL it, I'm going to get 12x squared plus 20x minus 6x minus 10. And if I expand everything here, then I should get 12x squared plus 18x minus 2x minus 3. And I can reduce. I have like terms right here and like terms right here. So I can reduce that to 12x squared plus 14x minus 10 is equal to 12x squared minus 16x minus 3. So we can do a little bit of kind of fancy math here if we want. We have, well, maybe I'll just go through it step by step. So I can subtract 12x squared from both sides, and you're going to see that it actually cancels right out, which is awesome. So now I have 14x minus 10 is equal to negative 16x minus 3, and then I can add 16x to both sides. And we can also add 10 to both sides. Oh, something went weird here. Ah, I see what happened. This is supposed to be positive 16, sorry. So if that's positive, that makes this subtracting 16, and this subtracting 16. Easy to make a mistake here. All right, so positive 16 subtract 16x goes away, positive 10 and negative 10 goes away. I'm left with negative 2x is equal to negative 3 plus 10 is 7. And then I can divide both sides by negative 2. And I'm left with x is equal to negative 7/2. Neither of those are my non-permissible value, so this is probably a good solution. You could verify by plugging it back into the original equation and solving both sides to see if they're equal to each other. All right, the next one. We have 5t minus 2 divided by t plus 1, all subtract 2t minus 1 divided by t minus 3, and that's all equal to 3. So we have multiple terms, so we're looking to multiply every term by the lowest common denominator. So what we're going to do is we're going to multiply everything by t plus 1 times t minus 3. So if we were making a common denominator, we would be looking to make it that term. So what we're going to do is we're going to multiply every term by that. So we're going to go t plus 1 t minus 3 multiplied by 5t minus 2 multiplied by t minus 1, or divided by t minus 1, sorry. I'll subtract t plus 1, t minus 3 multiplied by 2t minus 1. I keep putting brackets on the end of there. It's such a habit. Over t minus 3, and that's equal to t plus 1, t minus 3 multiplied by 3. Let's scroll over here. Okay, does that make sense? So what's going to happen when we do that is t plus 1 and t plus 1 cancel, t minus 3 and t minus 3 cancel. So now we have t minus 3 multiplied by 5t minus 2, all subtract t plus 1 multiplied by t minus 1, and that's equal to, I'm just going to rearrange this, 3 multiplied by t plus 1, t minus 3. So what we did there is we basically got rid of any t value in the bottom. What I should have done before is looked at our initial equation. That's not what I wanted to do. Look at our initial equation and come up with my non-permissible values. So I'll do it off to the side here. T cannot equal -1 or +3. Okay, now we can expand everything. So we're going to FOIL the first term, and we're going to get 5t squared minus 17t plus 6. And then we're going to FOIL the second term, where we're going to get 2t squared plus t minus 1. And that's all going to equal, well, if we FOIL, I'm just going to do this over here. Or no, let's do this 3. And then if we FOIL that, we get t squared minus 2t minus 3. And then what I'm going to do is I'm going to rewrite this, because we know if we have a subtraction here that -1 also needs to factor through. So I'm going to rewrite this as 5t squared minus 17t plus 6 minus 2t squared minus t plus 1 is equal to, and then I'm going to factor that 3 through there. So now I've got 3t squared minus, 6t minus 3. So we're just trying to solve for a value of t, just to remind you of what we're doing. So I'm going to combine my like terms on this side, 5t minus 2t squared. That's going to give me 3t. Then I've got -17t minus t is going to be -18t. And then I'm going to have +6 and +1 is going to be +7. It's a t squared. So you can see here I can now start simplifying. I can subtract 3t squared from both sides. And they both end up canceling, which is really nice. And now I can do my 2 steps of algebra. So I'm going to add, I wanted that in blue, add 6t to both sides and subtract 7 from both sides. And when I do that, I get, oh wait, that's supposed to be a 9, isn't it? Look at that, this 3 right here. Again, just the weekend, I'm just making mistakes. This was supposed to be 3 multiplied by -3. So that should have given us -9, -9, -9. There we go. So -6t plus 6t goes away. +7 minus 7 goes away. -18t plus 6t is -12t. And -9 minus Negative 7 is negative 16. Divide both sides by negative 12. And I get t is equal to 16 over 12, or if we reduce that, 4/3. And then we should check that and verify. I'm not going to because I used up all my space, but we should check and verify. Oh man, that was a long one. Okay, maybe we'll do this one in class. I will put a sticky note here, do in class, just so that you don't stay too long. Thanks for watching. Don't forget to like and subscribe.